So what we discussed last class, we just solve one problem. Okay, we solve one problem regarding the three moment method or Clapeyron's method. So we solved one problem and we did shear force and bending moment diagrams and free body diagrams, how to draw shear force diagram with ease, very easy. So within small, and later we give another problem which has two sides fixed end moments. All three has a fixed end moments, MA, MB, MC. Then we have to assume two extra spans, A dash and AB. So because in this three moment method we get only one equation which has three unknowns, MA, MB, MC. So but we need extra two equations to solve MA, MB, MC. That's why we assume A dash is one support and C dash is another support. We took it and later we solve it, and later I directly give the values of MA and MB, but sorry, these MA and MB are wrong values. Just I give wrong value. Okay, no problem. So exact value is what is that, like exact value? I can't see it. So exact value is 42.66. Otherwise check it. Very simple. So these are the three equations, na? Three equations. You can easily do it. Otherwise just check it. So MA is equal to MC. We already know it because C it is equally distributed, na? MA is equal to MC. So no need of three equations. See, it is just MA is equal to MC. These are the equations, MC, MB, MC, MB. Okay. So just it. So already has two equations now. So this is 1, this is 1. 1 minus 1. Just minus it. You will get what is it? 24 MB. Just see it. Just this is taken a 1, this is taken 2. 1 minus 2. 24 MB plus is equal to the 1024. Are understood? So 1024 divided by 24, we will get 42. MB is 42.66. Are understood? So same thing, MA is also 42, MC is also 42.66. Wait 1 minute. 1 minute. So last time I just directly gave the values, but those are the wrong values because I saw some other page. Okay. So see it is. So the diagram look like. So what is 6? 42, 42, 42. That's it. Okay. These are the negative. So negative, positive, positive, negative, negative, positive, positive. That is the diagram. Okay. So this is, I will correct it. Okay. I will correct it. 42.66, 42.66, 42.66. It will come like same. It will come like this. Sorry. No need of this. It will come like this. Benjamin diagram. Shear force also, like diagram is same thing. You can find out the values. Okay. I gave one so assignment. Anyone did appreciated. Otherwise, your problem. Okay. So today we will discuss another. We will discuss another things. 13. see it. For suppose any of the support is sinking is common. How we get the moments? How we get the moment? Okay, if any of the support is sinking, how we get the moments? That is the problem. If you see, we already said that we already discussed in this. So if the supports are like this, if any of the support, one of the support is sinking, how it happened? How it is happened? So it is like moment is like, so that's why it will come like this. This is, so see, it's a sagging moment, it's a hogging moment. We already know what is that value, 6ci by delta by L square. Understood? 6ci delta by L square. We already know it. But if it is in a continuous beam, so something take it, continuous beam. Suppose any of the support is sinking, how we get the moment? So we already know. So this is A, this is B, this is C. We already know summing M1 L1 2 M1 L1 plus L2 plus MC plus L2 something blah blah. We already know without the sinking of any support. If one of the support, maybe B is sinking, or C is sinking, or A is sinking, how we get the MA or MB MC resultant? How we will get? So we will get it. See, it is the same formula, but we just modified it. Okay, we just modified it. So one thing we have to discuss in pre-assumption, that if you see it is, if any something, three supports are there, would just see it. If B is sinking, MA is affected, MC is also affected. This is B, this is C, this is A. A is affected, B is affected, C is affected. Are understood? So because in this three moment method, we taken two spans, L1 plus L2 L2. We consider two spans na? At a time we consider two spans. At a time we consider four are there. We will consider first, we will consider later. Are understood? We will consider two spans, and that means three supports. Na? So if you see, any middle support is sinking, MA is affected, MB is affected, MC is affected. Otherwise, if you take in something like, if you see it is B is sinking, so if you just consider like this is A dash, if you consider these three spans, A dash, A, B, only B is sinking. B is sinking means, if you see it is 1, 2, 3 supports are there. We consider these three, but only this support is sinking. So this support is sinking means, so like, okay, I will write it. This support is sinking means what will happen? Only this value is affected, not this value. Are understood? So okay. So those are the different conditions. Center support is sinking. MA, MB, MC both are affected. Three are affected. But if only edge value is sinking, only MA and MB is affected and not MC. Are understood? So now also one thing you have to observe it. So same thing. Take an example. Say it is, if B is sinking, A will get hogging moment, but B will get sagging moment. Are understood? Same thing. Let's just see it is. So A will get hogging moment. So B will get hogging moment. So what you understand? So if without the supports, without the sinking of the support, something, these three values has something value. MA is there, MB is there, MC is there. So once support is sinking, once B support is sinking, the MA value will increase. So because already MA value we get something hogging moment is there, fixed moment MA is hogging we get. So once B is sinking, again MA will getting hogging moment only na? Again A value, so again A has a hogging moment, so again say hogging moment will come. A value is increasing but B value is decreasing because previously we get some hogging moment, negative moment, but once B support is sinking we'll get sagging moment. Understood? We'll get sagging moment. So B value will reduce it. Sir, how can we understand? How can we prove it? So we will do problem. I will show you. I will show you. Okay. B will. Okay. So what is the formula? So no formula. Same formula. See it is MA L1 2MB L1 plus L2 MC L2. We already know. Same 6Y1 X1 by L1 6A2 X2 by L2. So is equal to 6 EI delta by L square L. L. Sir, why L not L square? The C, it is a M into L units. So moment is 6 EI delta by L square. If you multiply with L, 6 EI by L. So moments are equal. If anything adding or subtractions, all dimensional formula is equal. Na? So this is MA into L. That's why only it will get L1. So 6 EA delta by L2. Delta 1, delta 2. So what is delta 1? What is delta 2? If you take in 3 supports, see it is. If you take in like this. So this is A, this is B, this is C. If B support is sinking, these two spans are we are considered. These two spans are considered. So if B is sinking like this something, if B is sinking like this, okay. So B is sinking some delta. So same, see it is AB is also sinking, BC is also sinking. Na? That's why if delta 1 and delta 2 are both same. So we consider A, B, C is a span, B is sinking. So what is delta 1, delta 2? Both are equal. Both are delta. No problem. Both are delta. So what is delta means? Not a support. Just a reference. Then with respect to. If ABC are there. A is sinking 2 meters. B is sinking 5 meters. C is sinking 3 meters. Like this. Then what will happen? A is 2 meters. B is 5 meters. C is 3 meters. What will happen? So delta 1 is what? Exactly, this is 2, this is 5. So only reference. See, it is only with respect to you will get moment. Understood? I already said if it is A, if it is B, it will sink 2 mm, it will sink 2 mm. There is no extra moments because both are settled down as it is. Understood? With respect to reference. So with respect to A, with respect to another support, how much it is sinking, then only we will get moment. Understood? So what is delta 1? So delta 1 is 3 meters because it is 2, it is 5. So delta 1 is 3 meters. Delta 2 is another span. This is AB span. For BC span, delta 2 is, this is 3, this is 5, that's 2 meters. Okay, there it is. Understood? Delta 1 is 3 meters, delta 2 is 2 meters. Understood? If just very simple problem like given it like this, B is sinking 5 meters because B is sinking 5 meters. With respect to A, it will sink 5 meters, or with respect to C, it is also sinking 5 meters. Okay, so that's why so delta 1 and delta 2. So most probably like given most conditions are like this. If anyone given like this also, you can directly take in delta 1, delta 2, and also positive negative signs also I will see it is delta 1 and delta 2 taken as positive. in these situations, in these both situations, delta 1 is positive, delta 2 is positive value. Okay, directly taken it is for this equation. So because B is in at center, B is in at center. So if you see it is delta 1 directly taken for MA will get hogging moment, MA will get hogging moment, and MC is also hogging moment. Then delta 1 and delta 2 taken as a positive. For suppose if you taken like this, for this A, B, C. So A is sinking, so A is sinking. So A is sinking. So only BC is not, so delta 2 is 0. But delta 1 is sinking something value. So delta 1 taken as a negative. Because see it is, so because see it is, A has what? A has get hogging moment. I understood. A has a hogging moment. In this situation, it will get hogging moment. So in this case situation, it will get sagging moment. This is the same equation. This is the same equation, but we have only two conditions, two different conditions. One is center support sinking. Second is edge support is sinking. Edge support is sinking. So at the center support is sinking, you will directly take it as a positive. No problem, because A and C. So we will choose. We discussed that if you anytime you draw show bending moment diagrams, we will take center of gravity from the C point and the A point. So because the formula derived from A and C as taken as the two supports. Those are the instrument, those are the control. So that's why say just feel it is A and C are above with respect to B. Take a positive. Take as a positive. See it is, if you take is A is below with respect to B, take as a negative. Same thing, same situation. If B is sinking, C is sinking with respect to B, taken as a negative, because it is a below, not a below, because it will get a hogging moment. See, it will get a sagging moment. C get a sagging moment. That's why it will take as a negative. That's it. That's the only reference points. Okay. So okay, that's the A and C. If it is reference with respect to B, it is below, then we'll take as a negative sign. Otherwise, if A and C are above with respect to B, take as a positive. Why it is negative, positive, negative? I already explained. This is sagging, hogging moments. So okay, are understood? That's it. Nothing more than this. So you will directly do the problem. You can do the problems. And also one thing, I directly explain it. If different spans has different flexural rigidity has, if different spans has different flexural rigidity, then also we can use this formula. That means what? If any span is there, span, if any span is there, this is has 2 EI, this is EI. So I think you already did so many problems to calculate the deflection and slopes which has different flexural rigidity. You already did, I think, in deflection chapters. If some span has, some portion has some different flexural rigidity, some portion has different flexural rigidity, you can easily do by conjugate beam method, I think. Na? So if it is bending moment like this, if it has a off EI, then you will directly like this, only taken like this, and you can directly support reactions. I think you did it maybe deflection chapter. So in deflections you can already did by the conjugate beam method. So many methods you can use it. Not only conjugate beam method, area moment methods also used for different flexural rigidity. So flexural rigidity means what? So E has most probably same, but only I has change. I means change means what? It's a width or breadth is changing. Like this, you can represent some maybe like this. Maybe it like this. You can represent also, because most probably E is same, because concrete or steel has same throughout the structure, but shape may be, shape or size may be different. That's why I changes. That's why flexural rigidity changes. That's why they will shown like this. This is also, if it is the case, we can also use same formula. So what is that? MA L1 2 MB L2 L1 plus L2, so MC L2 plus 6A1 X1 by L1 6A2 X2 by L2 is equal to 0 na? So divided by, this is E1 I1, so this is EI2, or otherwise EI1 EI2, and also see this is L1 divided by E1 L2 divided by EI2. So okay, and also this is reference of 1, this is reference of 2, same thing. That's it, same formula you can use it. For this span you can use 2EI, for this span EI, same. So otherwise if you add 6EI delta by L divided by EI1 divided by EI1, so this is cancel. So what will remain? 6 delta 2 divided by L2. This will remain. So you can use it. So we will solve problem tomorrow. Okay, for the different moment of different moment flexural rigidity. Okay, we will solve, not a big problem, just directly use it like this. Okay, so we will say one problem today. So what is the problem? So see, it is the same problem yesterday we did. What is it? This is the problem. We solve it once again, same problem. So because it is already we solved now. So 8 kilonewton per meter, 8 meters. Okay, so if support B is sink by 10 mm, okay, so support B is sink by 10 mm, so E is equal to the 2 into 10 power 8 kilonewton per meter square. I is equal to the meter power 4 for all spans. If B is sink by 10 mm, find MA and MB MC. That's this chapter. So if you see, just observe it, sir. See, it is some textbooks confuse you. Some textbooks they said that delta taken as a negative, delta taken as a positive. Some textbooks, if you see the textbook of strength of materials, R.K. Rajput, very good textbook. Strength of materials of R.K. Rajput. Mechanics of solids, very good textbook in color, very good, but they did wrong. For this method they did wrong. So like this they said that delta taken as a negative and they solved the problems. Those answers are wrong. So how can I know those are the wrong answers? Because I'm not a great than those readers. But how can I know? So we don't know. So assume it you don't know also. But one thing you have to observe it. So which one is wrong, which one is right, we will see it. So taken as a positive, taken as a negative, which one is right? We don't know. In textbook they write as a negative. They solve it some problems. I feel that these are the wrong. How can I feel that wrong? That's it. I would clarify you. If see it is, if B is sinking, see it is, if B is sinking, so what is the value of MA, MB, MC? How will it change? We already know, we already solve it. MA is 42.66, MB is 42.6, MC is 42.66. We just solved yesterday. That's it. We just solved yesterday. You get these are the values, negative moments. We already know it. Okay, we already know it. And if B is sinking, how it changes? MA will increase or will decrease? For general idea, how can, what is it? See, it is B is sinking. If B is sinking, see, MA, another extra, only for the sinking of the support of B, see, it is MA will get again hogging moment. MA will get again hogging moment. That's why it should be increasing. So MC also again it will get hogging moment. It should be increasing. MB, so MB has sagging moment. I understood? MA has sagging moment. I already said it's a sagging moment. So if you don't understand, see, it is just, it is a theta. It's a theta. So moment will arise to nullify the theta. So it will has hogging moment. It will has sagging moment. So previously it has a hogging moment. Now it arises a sagging moment. So compulsory it will go decrease. Are understood? It is increase, it will decrease. So use the formula what I said, negative sign or positive sign. We will see it is whether it is increasing or decreasing. This is the common sense. Those formulas are mug up. So in textbook I saw different readings and they did it. So later I thought those are the wrong answers, like this. Okay, so now we will see directly. Okay, directly we can solve the problem whether we'll see it is an increase, whether our common sense is right or not. Okay, see, directly taken it. So we already know it. We already know it's a C dash and A dash. Okay, so directly first we will do A, B, C is the three sides. A, B, C is the three sides, and also if you draw bending moments of as a directly taken as a simply supported, it will come W L square by 8, 64 and 64. This side of 4, this is a 4. We already know. Directly first is MA 8, 2 MB 16, MC 8 plus 6. Area is 2/3 of 64, 8, and distance is 4. Divided by L1 is 8, and again same will come, okay, is equal to the 6 EI. Are understood? EI, what is EI? EI is 2 10 power 8. That is EI is 100 10 power minus 6. That is 6 EI divided by L1 is 8. Delta 1, what is delta 1? B is sinking, na? B is sinking 10 mm. So okay, B is sinking 10 mm. So with respect to A is above B. Will get hogging moment. I understand. Will get hogging moment. So A is above. With respect to A, how much? 10 mm. So directly it's a 10 mm. So write in the meters. So again C is 10 mm with reference. So I already said if it is A sinking of another 5 meters, the reference is only 5 meters. If A is sinking 5 meters, B is sinking 10 meters, we have to take and delta is 5 meters with respect to differential settlement. So everyone, it is called as a differential settlements. Now I will write as a delta is differential settlement, not a settlements. Okay, differential settlement. That will be a good word, I think. So differential settlement. Okay, are understood? Differential settlement, that is a good word, I think. Differential settlement. Okay, so that's it. And again For C also same will come na, plus will same value, so what are those values? See it is, so MA into 8, so 32 MB 8 MC is equal to this value. What is this value? We know 10024 plus 10024 is equal, what is this value? What is this value? So this will cancel, so it is 200 and 100. Okay, 200 100 and 6, so this is 10 power 2 minus 2. Okay, so 10 power minus 2, this is the cancel, will cancel. Okay, 6 12 1200, I think 1200 divided by 8. Okay, this is 1200, this is 1 by 8, so second one also, this is also 1 by 8 plus. Okay, again this is delta 2 also same. So okay, that's it. What is that value? What is that value? 1200 divided by 4, that is 300. It is 300. Okay, that's it. The first equation is where to get. So now we will get second equation. Second equation is a dash a and b, a dash a and b. Okay, so I will write the span, otherwise you will confuse it. This is a dash, this is b. If you see, it is b only sinking, of 10 meters. Are understood? B only sinking of 10 meters, 10 mm. So this is delta 2, delta 1 is 0, delta 1 is 0. Write down the equation. Again, if you write down the equation, so MA dash of L1, these are all 0 because this is a imaginary beam. Okay, so no need. So 2 MA of L1 0, M2 is 8, so MB of 8 plus, so you will get the same, I think you will get the same. Okay, this is 0, this is same thing, so this is 10024 is equal to the 1200, same. Otherwise I will write like, otherwise this delta 1 is 0, so no need. So delta 2 6 EI delta 2 divided by L2, but this delta 2 you have to write as negative sign. Are understood? Negative sign. So same value 1200. Okay, are understood? 1200 will come, 1200 1 by 8. Okay, 1200 1 by 8, same, delta 2 same. So this is negative side. Okay, are understood? So where it is positive, where it is negative, you have to understood. So what, write it, 16 MA plus 8 MB is equal to minus of, what is that, 1200 divided by 8, it's 150. This is second, this is first. You can took third equation also, but no need because we already know MA is equal to MC. We already know MA is equal to MC because this is a similar diagram. Na? So otherwise, if you write down the third equation, you will get same thing. Because most probably, so those two spans has different loading, then you have to write down the third equation also. If it is different loading, MA is different, MB is different, MC is different. But if it is similar diagram, similar loading, so we can also imagine, directly conclude that MA is equal to MC. This is the third equation. You can use it. So MA is equal to MC. So same thing you will get. See, it is, what is that equation? What is that equation you will get? MA is equal to MC. So 16 we write as MA na? So 16 MA is equal to MC, so we will use it. This is also MA. What is that will come? 16 MA plus 32 MB plus 2048 is equal to 300. Okay, so that's it. So So if it go like this, what is the value? 2048 minus 300, 1748. So 16 MA plus 32 MB minus 1748. This is a third. And if it is C, it is 16 MA plus 8 MB is equal to the 1024 plus 150. What is that value? 1174. This is a 4. If you see both are 3 minus 4, we will get what is 24 MB will get 1748 minus 1174. So 574. So answer divided by 24. You get 23.91. MB is 23.91. Negative. Okay. Arguing moments. So if it is MB is 23.91. What is MA? Just place it or place it. What is MA? MA is 61.41. So whether these are the right or wrong, sir? So we use positive sign, negative sign as per our convention. What you said, sir, you said we did it. So whether it is right, some textbooks are different method. Some textbooks they just use it. This is a negative sign. This is a positive sign. Opposite, quite opposite. Take this. If you see it is, if you take and this is a negative sign. If it is, this is a negative sign and this is a positive, you will get different answer. You will get MB is 63.41, MA is 23, MC is 23. You will get like this. Some textbooks write like this. So whether which one is right? So what we did, we get this one. Some textbook like got this value. Which one is right? How can you said it is right? How can you said this is right? So I said that this is a right. This is right. Our convention of taking delta sign is right. How can you say? So because I already said that. So if B is sinking, what will get? So compulsory previous values, compulsory if you see the previous value, MA should be increased, MC should be increased, MB should be decreased. Because B is sinking, A has getting again hogging moment. C has again getting hogging moment, but B experiences sagging moment. So compulsory B is reducing, A, C and C should be increasing. So we did the problem like our convention, we solve it. MB is 23, MA is 64, same thing, MC is also 61. So that's it. So this is the right method, this is a wrong. Some textbook use like this, okay? That's it. So if you write down the bending moments, bending moment diagram, bending moments, no problem. This is a 64. These are all positive. So fixed end moments are see, MB is 23, MA is 61. So this is 61.41. This is value is 23.91. These are the fixed end moments. Okay, these are the fixed end moments. So these things are nullified. These things are plus or minus nullified. So remaining value only will get, this is negative, this is positive, these are the negative. If you write down directly, if you find out the shear force later, you find out the section by section, what will come? It will come like this. It will come like, how can you like? See it is. It will get like this. No problem. Both are same. This is a positive. The remaining portion I can write it. Negative. So this is a 21. This is 61.41. So like this. Okay. Understood? So shear force, same thing. Much no needed. Shear force, if you write it, it will come like this. It will come like this. Again it will come. it will come. So you have to find out the what is the value. What is the value? You can find it. Okay. So deflection diagram. So deflection diagram. So you can write it. Deflection diagram. You can write like this: sinking by 10 mm. This is not mm. Okay. Just I will write like this: deflection diagram. This is the deflection diagram. Okay, I understood. And again, you will get see it is how many 2 point of contraflexures are there. So you have to mention where it is. This is a point of contraflexure. This is a point of this is a point. This is a point. Okay. So this is the deflection diagram. Like this, na? So that's it. That is the problem. Okay. So I plan to do another problem also. Another problem also. Can I do? Can I do? It will get another half an hour. Are you okay? Otherwise we will do, because tomorrow I want to solve another 1 or 2 problems. I will conclude this topic. So okay, no problem. I will do another problem again 15 minutes or 20 minutes, because tomorrow I will solve miscellaneous problems too, and I will conclude the second units. Okay, so don't hesitate. It's taken another 15 minutes. Another 15 minutes. I don't do any calculations. I have values, so I will do problem. So this is a loading. Okay, 50 kilonewton, 50 kilonewtons, 2 2 2. This is 8, and again it has 2, and again it has a load of 20 kilonewtons. So okay, so and again I is 110 power 6, same values. E is 2 into 10 power 8 kilonewton per meter square. So if you see it has overhang. If it has overhang, how can we solve the overhang problem? How can we solve overhang problems also? Just no need to discuss it. We will solve it. Overhang also. This is the overhang portion. Are understood? And also B is sink by 10 mm. So what is B? He said that this is A, this is B, this is C. B support is sink by 10 mm. What are the moments? He has task. Okay, can we solve it? We will solve it. But first thing is how to solve overhang. So if any overhang is there, nothing problem. If you see it is, just draw a free body diagram of overhang. Just overhang. So it is a 20. So compulsory, it is 20. Are understood? It is 20. And also if you see it is 20, it is a 2 mm. How it is balanced? How it is balanced? It is balanced only. See it is. So compulsory it has a moment, na? It has a moment. A has a moment. So how can it balance? What is balance? It's balanced by 40 kilonewton meters. Antena? It's okay. So that's it. If you understand this is a value, so this is a moment. Otherwise if you don't know, otherwise it can't balance, na? It can't balance. It is also a free body. You just write down the overhang portion. It is also a free body, so you should be equilibrium. So it is a 20 kilonewtons. So compulsory it generate a moment. What is that moment? 20 into 2 minus of m1 is 0. So both are. So what is m? What is m? 40 kilonewton meters. That's it, na? So that's it. Once you got that m, what is m? M is, this is A. A has a moment of 40 kilonewton meter. From the left side, it got a 40 kilonewton meter. Are understood? So otherwise if you take it as A is a only support. So automatically it will come A. It will come like 40 kilonewton meters. Automatically it will come other side also, it will come 40 kilometers. Otherwise A is not balanced. So A is also one giant. A is a giant. It should be balanced. So that's why already one side it will get 40. Other side also it should be compulsory get 40. Then only A giant is stable. A is joint is in equilibrium. So understood. So first already we got in which direction? Hogging, na? It's a dogging. So MA is hogging 40 kilonewton meter. We already know it. So one already we got it. So from other side also it's compulsory, should be compulsory 40 kilonewtons. Then only A is fixed. So A is stable. So A value we got it. Before proceeding the exam, before you enter into the match, A value we got it. Otherwise, if you see, if it is like A has zero moment. A is outside, outside edge, so A has zero. If it is some overhanging portion is there, some load is there, to balance that load, A generates some moment. That moment is this value. So same thing out from other side also it will get same moment, then only its joint is stable. Okay, so previously it is zero, now its A has a 40 kilonewton meter hogging moment. That's it, not a big deal at all, not a big deal to discuss overhangs. Okay, A already we know it, A has 40 kilonewton meter. Later process same thing, so okay, we will directly draw free body bending moment diagrams here. So what is the free body bending moment diagrams? Free body bending moment diagrams, no need of overhang portion, already we solved it, no problem. So remaining portion, see it is a 50 50 2 2 2. What will get? So these two supports will get 50 50 into 200. So how will get? How will get? Like this, na? Like this. This is 100, this is 100. You will get free body bending moment diagram. So for this, so next portion will get a bending moment diagram. So that is 8. So what is that load? Load also I will give 8. So 8 will get, what is that? 64. Okay, so those are the free body. So this is a overhang, no need of, because we already know. So directly take A, B, C, and also B is sink by 10 mm. Are understood? B is sink by 10 mm. You just take it. B is sink by just 3 supports. B is sink by 10 mm. Take like this. Just imagine. So reference. This is A, this is B, C. So write down MA. L1 is what? L1 is 2, 2, 2. This is 4. This is 4. What is centroid? Compulsory it is 3. MA. I directly write it. Values also. Okay. What is L? MA is 60. 2. MB 6 plus 8. MC 8 plus 6. Area is what? 100 into 2, 200. So this portion is 100, this portion is 100. 200, 200. It's a 400. What is that area? That area is 400. Central distance from A is 3. Divided by L1 is 6. So second is 6 into 2 by third of 64 into 8. That is area. Central distance is 4. Divided by 8 is equal to the 6 EA. 6 EA. EA is, I write it. Same thing. What is that? Same values na? EA is will get EA will get 6, 2, 10 power 4, 10, 10 power 2 into 10 power 4. Directly will get EA. Multiply with of EA, 2 into 10 power 4. Okay. Directly you will get 2 into 10 power 4. Okay. EA. So 6 EA into delta. Delta. What will taken positive or negative? It's a positive value. How much value? It's a 10 value because A is above B. A is above B. How much? 10 mm. So taken positive 10 mm. Divide by L. So second thing is for C. C is above B. How much? 10 mm. Same thing you will get. Divide by L2. L2 is 8. Understood? Just solve it. Because see, it is MA, we already know it. What is the value? Minus 40. MA is what? MA is minus 40. Understood? We already know. So directly solve it. What we will get? You will get 14 into 24 MB plus 8 MC is equal to the, how much you will get? You will get, see it is, I will write like this. This value is, this this value, this total value will get 350. Okay, this total value is 350. This will get 6 cancel. This is 1200. This is 1024. We already solved this previous one, 1024. This is 1200. This is 350. So how much you will get? You will get minus 1754. And then that's it, na? 1200 plus 1024 minus 300. What? 350? Yeah? Minus 350. What will get? 1874. That's it, na? That is the one equation. One equation. So second equation. So because we have two unknowns, MB, MC. So second equation is, we'll took actions C dash. So L is 0. Okay. So we'll took it. So now B, C, C dash is a giant. So take a free body diagram. Free body. This is 0. This is same thing. 64. From this portion, it is 4. Okay. Are understood? Directly write it. Directly you can write it. MB into length is 8. 2MC 8. MC dash is equal to 0. MC is dash is 0 na? 0. No need to write. Plus area 6 into same thing. 2/3 of 64. 8 into 4 divided by 8. Second is 0 because this portion is 0 na? Is equal to the see, it is B is sinking. Are understood? In this portion, this is C, this is B, this is C dash. B is sinking. B is sinking. B is sinking. So how much it is? 10 mm. So in which B get hogging moment. So negative sign. Hogging moment. Chi. Negative hogging moment. Chi. B gets sagging moment. So we already know it. This is the formula derived from only for sagging. These hogging moments. B get sagging moment. So in this B is, otherwise B is there at below 10 mm with reference to the C. With reference to the C, B is below 10 mm. So we will take negative sign. Okay. Same thing. 6 EI. EI na? 6 EI you will get 2 into 10 power 4. And how much value? With respect to differential settlement is how? 10 power minus 3 divided by span length is 8. But you have to take in this value as negative sign. So where it is positive, where it is negative, you have to understand. So take a negative sign. Na? So that's it. That's it. So what is that value? So you already know this value is 1024. So what is this value? This value is 150, I think. This value is 150. So what is the 1024 minus kadapa? It will come outside. It will come after this equal. It is negative and negative. Total negative. 1024 plus 150. What is that value? 1174. So 8 MB plus 16 MC will get minus 1174. That is second. So that is first. This is second. Okay. Once you got two equations, solve it. 8 MB. So 28 MB, 8 MC. So okay. Can you solve it? Two equations, two unknowns. What you will get? What you will get? You will get. Otherwise, if you take a calci, go to the mode setup. Go to mode setup, and fifth is equation. Fifth is equation. So in equation, just press it 1, and you will get two equations, two unknowns. You can easily solve by calculator. By your calculator. Are understood? By your calculator, what we will get? MB is 53.62 and MC is 46.52, negative signs. That means hogging moments. Okay. So that is kilonewton meters. Units are important. Everywhere you have to write it. That's it. Na? That's it. MA we already know. MA already know, minus 40. Otherwise, if it is not there, if the overhang is not here, MA is 0. If it is not the present of overhang, see it is. If you cut it the overhang, so MA is 0. We already solved those such type of problems already. MA is 0. Just overhang is there. To balance that overhang portion, MA moment is generated in a portion. Are understood? Just take it is. This is 20. So this is a 20, but it has a support. It has support. Compulsory to balance that, generate a moment of like this. Are understood? To generate. Are understood? So then only it will be equilibrium. Otherwise it can't equilibrium. Okay, that's the overhang portion. So once you got it, you can easily draw free body diagrams or bending moment diagram. First I will draw bending moment diagram. So first I will draw bending moment diagram. So M, okay, so no need to write like this. So with respect to length I will write. This is only 2 meters. Next is 6 meters. Next is 8 meters. Okay. What is? I will try bigger. Okay. This is what? 100. So next. This is what? 64. And this is, we'll just neglect it. Wait, we will write later. So next, fixed moments. MB is 53. So this is 53. MC is 46. And MA is what? MA is also 40, negative 40. So what will come? It was 40. Okay, 40. So this is 50. So increase na? Increase. Just a symbol of 56. Next 46. Very small decrease. 46. This is 40. This is 53.62. This is 46.52. Okay, this will collapse it. This will collapse it. Okay, this will collapse it. Only remaining portion is this is positive, this is positive, this is negative, negative. And also what is for MA? MA is 40. But what is for overhang portion? Overhang portion is, see, it is overhang portion is, this is overhang portion. Okay, so this is 20. What is the bending moment diagram? What is bending moment diagram? Bending diagram is total hogging. Total hogging, na? So this is negative. So like this is total 40. Are understood? If it is a 40, it is a 40. What is the free body diagram? What is the bending moment diagram? It is a 40. Everywhere is 40. So sorry, everywhere is 40. Not sorry. So what is free body diagram? So what is bending moment diagram? It is a 40. It is a 0. Are understood? It is 0. At this location is 40 and it's hogging moment. And it will go 0. So total it is a hogging. Total it will hogging. So you can write it like this is a 40 and this will negative sign. Are understood? This is a bending moment diagram. You can directly write it. You can directly write the bending moment diagram. So and also shear force. Find out the shear force. You have to draw free body diagrams. So I will write a free body diagram of first free body diagram of this. This value is what? 46.52. So this is of 8 kilonewton per meter. This is 8 meters. We don't know this value. This is, I call it as RP1. This is RC. Okay. So what is the RP? Moment at B is, again it's a 53.62. That is a free body. That is a full-fledged equilibrium body. There is a free body. Are understood? Find out RC. Find out RC. RC into 8 minus of 46.52. So again, so this this is minus of 8 into 8 and 4. Okay, so 4 and will come like 53.62 is equal to 0. That's it, na? That's it. What is that value? 64 into 4 plus 46.52. Answer minus 53.62. Answer divided by 8. It will come as 31.11. Understood? It will come as a 31. Okay, 31.11. Again, I will calculate once again. 64 into 4. 64 into 4. Answer plus 46.52. Okay. Answer minus 53.62. Answer divided by 8. So 31.11. This is RC1. RC. Okay. What is RB1? So totally 64 na? Total load is 64. 64 minus answer. It is 32. 32.88. So this value is 32.88. So what is next free body? Same again. It will come RB2. This is the value of same hogging moment na? 63.52. 53.52. So what is that load? Load is 50. 50. Again it is C. RA1. RA1. You can write it's 1, 2 or nothing. Yeah. So that's it na? So and also its moment of 40 kilonewton meter. That is the free body diagram. So it has 53.62 at the support at the B end. 53.63 is the moment. At the A end, 40 is the moment. Both are hogging moments. Are understood? The remaining load is, and we will apply the supports. So write it. Write it. RB2 into 222 6 minus of 53.62. Okay, minus of 53.62. So minus of 50 into 4 minus of 50 into 2 plus 40 is equal to 0. That's it na? So 50, 200, 100. 100 plus 53.62 minus of 40. Answer divided by 6. That is 18.93. That is it. What is 18.93? That is once again I will get 300, 200, 100, 353. 300 plus 53.62. Answer minus 40. Answer divided by 6. Answer divided by 6. Sorry, it's a 52 point. RB2 is a 52.27. So this is a 52.27. What is that value? 100 minus 52 minus na? 100 minus answer. It's a 47 point. Same direction. 47.73. That's it. That's it. And also if later this is the free body diagram. This is the 20. This is of RA2. You can call it as a moment is 40. So what is RA2? RA2 is 20. Compulsory it is 20. It also should be 20. So those are the free body diagrams. So based on the free body diagrams, can you write it? Shear force diagram? Very easy. Very easy. See it is. See it is. Very simple. Just what is RC? RC is 31. Directly write 31. Okay. Directly you can call it as a 31. Otherwise directly write as 31. Okay. Take a 31.11. So what is RB2? RB1? RB1 is 32.88. So taken this is a B. This is a B point. This is a 32. 32.88. So how it is vary? Vary has. It is a uniformly distributed load. How it is vary? It is 31. It is 32. It will come like this. That's it. That is for this span. Later, see it is later span is. So next AB span. Take it is RB2 is what? 52.7. So if it is topwards, compulsory it will downwards. What is it? 52 na? So I will like write it. This is a 52 point. What is that? 27. 52.27. Are understood? So that's it. So if it is 52.27, so next it will come to like this. It is a 2. There is no shear force. Up to 2 meters there is no shear force. Suddenly it has 50 opposite direction. 50 opposite direction. So it will come like this. Opposite is 50. Opposite is 50. Okay, so opposite is 50, it is only 2. So later up to 2 meters, there is no change at all. Next 50 meters. Then again 50. So then again 50 means 50. 50. Huh? 50 minus 2.27. So 47.23. So it will come 47.73. Because if you see it is RA is 47.23. It will come like this. Are understood? Are understood? It is RA is 47.23 na? RA is 47.73. 47.73. So just write a 47.73 and is 50 down and again 50 down. It will come 52.73. That's it na? It's end. So if you see again RA2 is 20. So this is a 20. 20. So at this location again 20. So negative. So this is the shear force diagram. If you see, observe the shear force diagram, you can get the values of support reactions. What is the support reaction of RA and RB? Just see the shear force diagram. Just see the shear force diagram. It is 32.88 and it's a 52.827. 52.27 plus 32.88. That is 85.15. That is the shear force at B. Are understood? Otherwise, if you see RB1, RB2, total combined will get reaction at B. Otherwise, if you see the shear force diagram, then also that is the reaction. So what is the reaction at A? 47.22, 47.73 plus 20. So 67.73. Otherwise, observe it. So 47.73, it's a 20. So what is the total shear at that location? That is the shear reaction. So that is the reaction at A. Okay. So this is 85. Understood? So this is 85.15. This is 67.73. That is the reactions. So we got the reactions. And also if you draw deflection diagram, so you can draw it. You can draw a deflection diagram. It will go like this. It maintains some slope. And also how many point of contraflexures are there? See, again 2 point of contraflexures are there. It will go like this. It will maintain some slope here. It will maintain and it will come back the position and it will maintain, and again it will maintain some slope and it will come like this. Okay, there is no slope here, see, but he has a slope at B, slope at A, because this is a giant. Based on the loading, may it will come, may it will go. Okay, some other chances, may it will come. If you see it is, if it is A, B, if you see, observe it, maybe most chances are there, it will go. It will maintain this slope theta and the theta. It will go like this and like this. And it will go like this. Okay. So you need to mention point of contraflexure, 2. That is the deflection diagram. So okay, deflection, shear force, bending moment, everything we draw. We draw it. So that's the end of the story. So you can solve the overhang beams. You can solve if any sinking of the support is there. And tomorrow we will solve some miscellaneous problems of any 1 or 2 problems. Then close the second unit. Otherwise, if you have any doubts, ask me. Otherwise, tomorrow, next class, we will solve another 2 problems. Miscellaneous problems. Okay. Overhanging, we solve. Any support is sinking, we solve it. So, okay. So, tomorrow we will solve different flexural rigidity. Nothing more than this. Same thing, same procedure, but we just change the EI value and same use the formula. That's it. Okay. That's it. That's it. These are the values are not in my notebook. That's why it took some time. I will do along with the teaching. Okay. That's it. End of the story.